This is page 739. How do I forget these initial conditions? Yeah, just forget them for the time being. How would I solve this one? Just say you had that. We'll come back to the go ahead. Yeah, put it into the quadratic, into your quadratic equation. Okay, if you do this, you put it into a quadratic equation. Your solution, okay, is going to be. Go on, someone tell me what the characteristic equation is going to be. Yeah, m squared plus 7m plus 10 is equal to 0. How do we solve this quadratic? How do you solve this quadratic? Come, we should all be able to solve this quadratic. Yeah, m plus 5 and m plus 2, isn't it? Yeah, because 2 times 5 gives you 10, and if you add them, you get 7, don't you? 5 plus 2 gives you 7, so it's 5 and 2. So m1 is equal to minus 5, and m2 is equal to minus 2. Yeah? Okay, so this is too high up, isn't it? Okay, what sort of solution have I got? Real, not real and equal. Yeah, real and different, sorry, real and different. Real and different, so if I've got real and different, what's going to be my general, I don't know if you can remember, what's going to be my general solution, or I is equal to what? It's real and different, minus 5 and 2 are real and different. Yeah, ae to the minus 5x, you've got 5t in this case. Doesn't matter anyway. Go ahead. Plus be to the minus 2t. Yeah, okay. Now at the moment we've got too many. Like I said, if this is a sort of physics type of problem anyway. It's if you apply Kirchhoff's law to a circuit, that's the equation you get. Yeah. I don't know if I might tell the linear algebra group, but Kirchhoff he's done amazing. You know, he got his name to such a simple rule, which any of you could have thought of. You know what Kirchhoff's law actually says? Yeah, the current entering a node. Okay, the current entering a node. If this is a node, the current entering a node I. Okay, the current entering a node I is equal to the current leaving a node. So I1, let's say I2, and I3, and all he says is I is equal to I1 plus I2 plus I3. You know, I mean, you could have all thought that. Amazing. Kirchhoff's become immortal because he thought of such a simple rule that the current entering a node is the amount of current leaving a node. Okay, I mean, normally someone Newton or Archimedes or Euler or someone did such, great work. Kirchhoff managed still remember for doing such a simple rule. And his voltage law say the same thing. The applied voltage is equal to the voltage drop across each component. So, do you have a question?
It's like the hydrogen emission lines.
Sorry?
It's like the hydrogen emission lines, they're named.
Hydrogen emission lines?
Like linemen.
Sorry, what?
The lines for hydrogen emission are named where all of the M's are named.
Are all M's?
No.
I'm not too sure what you are. I don't get... I'm sorry. One thing you must realise, I might show off that I know a lot of physics. I don't really know any physics, if that's what you're thinking. I don't really know any. I mean, I did try to learn, when I was writing the book, I tried to learn some engineering. And when I said to students, oh, look, if you just apply Kirchhoff's law, you get this. And then students said, no, we haven't done this in electrical principles or whatever. And then I go, hang on, I'm doing the wrong thing. I don't want to learn it. It's best for me to be ignorant of that and not learn it, and teach in a way that, so all this work doesn't rely on you knowing. But sorry, you might have a valid point. I don't know. I'm not. One thing you must know, I do not know any physics or engineering. I mean, some students come up with me, ask me engineering questions and say, oh, can you answer that? I go, look, I don't know any engineering. I've never done it, Anyway, I know some maths, yes. Not that much, but I know some. Anyway, we can't find A and B. It's a useless solution. That solution is useless. Why is it useless? I mean, if you join on a student, okay, you've got a business problem, and this is you solve the differential equation, you get the solution, you'll say, well, that's useless, I don't want this. What good is that to a join on a student or a physics student? Maths student, we don't really care. It's useless, fine, that's okay. I glorify in that, I love that, I think it's, I quite agree with Hardy, they find it useful in mathematics, I'll give it up and do philosophy or theology. Some philosophy students here as well, actually, so, yeah.
You still don't have natural value.
Yeah. What good is that? You don't know. How can we find A and B? In this case, you can find A and B. In the previous case, you couldn't. You had no more information. You couldn't find A and B. Yeah. And here you can. Why can you find A and B? What does this tell you so you can find A and B? What does it tell you about this differential equation? Go on, Hannah. Yeah, which values? Yeah. T equals what? Sorry? Yeah, T equals 0, I is equal to 0. Yeah, you're told that. You're told when T is 0, the initial current is 0. So when you put T is 0 in here, okay, you take this, you know 0 is equal to A e to 0 plus B e to 0. What's e to the 0 equal to? Yeah, A plus B. So we know A, what we do know now is A plus B is 0, or A is equal to minus B, isn't it? Yeah? So we know if A is 1, B is minus 1. We know that. If A is minus 1, B is minus plus 1, yeah? If A is 2, B is minus 2. We know that. We know they're going to be opposite. So they're not, one of them is not smaller than the other in magnitude, in size. They're the same, okay, but a different, what do you call it, polarity, yeah? We definitely know that now. But we can't, you know, you could say, I might say, okay, it's 1 and minus 1. And Patrick might say, no. What about 666 and minus 666? And they'd be quite right. You know, infinite number of solutions here. So I want to find particular values for A and B. This is why it's called particular homogeneous solutions. Yep. Yeah, exactly. You're also told, okay, if you go back up here, look, you're also told at T is 0, di dt, whatever that charge, I can't remember electrons what that represents, okay? Di dt represents something is equal to 0, yeah? Okay, so if you put those values in, when T is 0, di dt is 3, so we've got to find di dt, don't we, yeah? We've got to differentiate this, yeah? Okay, di dt. So if we differentiate, what do we get? We get di dt, yeah? If we differentiate that, what do we get? Sorry? If you differentiate this, what do you get? Go on, Mohammed.
Minus 5a.
Yeah, that's right. Minus 5a e to the minus 5t. Yep.
Minus 2b.
Yes, exactly. Minus 2b e to the minus 2t. Yeah. Okay, that's what you get. Yeah. And now, what do you know? What are you given? What information are you given about this differential equation? So it's 3. Yeah, it's 3 when t is 0. So you're told when that is equal to 3 minus 5a e to 0 minus 2b e to the 0, and what's e to the 0 equal to? 1, isn't it? Yeah, 1. So it's minus 5a minus 2b. So you've got differential equations. What you've got is solve these differential equations. Not simultaneous equations. No. A plus b is 0, and minus 5a minus 2b is equal to 3. You solve those. I mean, you can solve simultaneous equations. You do them at GCSE. So you should definitely be able to solve those. If we solve those, if you solve those differential equations, let me see if I worked out a solution. Let me see, I must have worked out the solution earlier. So it was 1 and minus 1. B is 1, okay. We got B is equal to 1. A is equal to minus 1. So my particular solution is what? Y is equal to, so if you work them out, I mean, you can solve simultaneous equations. I'm not going to do that. You should know how to solve that. What do I get? What's my solution going to be then? What's my particular solution going to be? This is now useful. You know, if it's a practical problem, now it's useful to you, the solution. But what's it going to be? Well, just kind of a blank there, can I? And that's useless to you at the moment, a blank solution, isn't it? Yes, that's right, exactly. Here's your A, isn't it? Yeah? It's AE to the minus 5t plus BE to the minus 2t, and you've just worked out that A is minus 1, okay? A is minus 1, so you get minus E to the minus 5t, and B is 1, there it is, B is 1, E to the minus 2t, yeah? That's what your solution is. That is your solution. Now that solution is definitely useful to you. Okay, let's have a 10-minute break then, shall we?
Is that all right?
Yeah.
Is that what it says?